We're going to focus on probability density functions. So probability density functions for continuous random variables are just a way to visually represent or to use a function to describe the probabilities. Okay, now probability density functions, or PDFs for short, so it looks like some graph. Okay, and this graph will describe the probabilities of my events. Okay, now for some graph or function to be a PDF or a probability density function, there are a couple of conditions that it must apply to. Okay, so the first thing is that probabilities must always be positive. Okay, so fx should always be greater than 0. Okay, so again, that's just another way of saying all my probabilities should be at least 0 or positive. We never have a situation where we have a negative probability to describe something. The least we go is saying that it won't happen and say that it will be 0. Okay, so that's just saying my probability density function should always be greater or equal to 0. Okay, now my other condition is this. So it means that the area under my curve is going to equal to 1. Okay, that's just a way of saying that all my probabilities need to add up to equal 1. So this is a fancy way to describe that. So my probability, when my PDF goes all the way down to negative infinity and all the way to positive infinity, whatever it is, just the area under this curve is always going to equal to 1. Okay, so for example, if I have a situation where I want to find the probability where x lies between a and b, okay, then that probability will be described by the area under that curve. Okay, so not by like this height or anything, it's going to be by the area under the curve. Okay, so the area under this curve describes me the probability, and the area under all of this whole curve should be equal to 1. Okay, so again, I want you to focus on these two conditions. Okay, so if those conditions are satisfied, then my function will be a probability density function. So if we take a look at some of the questions, I have a function up here, which is described between two regions. So the first part tells me to sketch this graph. So here's my number plane, and I'm going to sketch fx is equal to 2x for that given domain. So my domain, when x is in between 1 and 2, my graph is going to be 2x. Okay, so that's just in between there. Everywhere else, my fx will be 0. Okay, and since at the top in the 2x, 1 and 2 is included, these 2 points are included, so we're not going to include these 2 points. Okay, these are open circles. So there I sketched it. Now in part B, it's asking me to state whether or not this is a probability density function or not. So for it to be a PDF, first of all, I need to satisfy my two conditions. So the first one is that I need my probabilities to be greater or equal to 0. I don't want any negative probabilities. So that, to see graphically, the fx should be at least greater than 0. Okay, so that looks like it's okay. Okay, it's got some zeros, but at least it's greater than it. Okay, now my second condition is that my area under the curve should give me a area of 1. Okay, so we're going to try and see if it gives me an area of 1. So the area under this curve, which is just 2x, just finding the area under here, okay, under 2x, between 1 and 2, if we integrate it and evaluate it, we get 2 squared minus 1 squared, which is 3, okay, which is not 1. Okay, so the area under the curve is not 1, meaning what? This is not a probability density function. Okay, so we need to consider and satisfy those two conditions. So let's take a look at the next question. So in this question, we still have two regions that that describe fx. And we're going to try and sketch it. So we're going to have the two different regions. So fx is equal to x minus 1 for when x is between 0 and 2. So between 0 and 2, we're going to have that graph. Fx is equal to x minus 1. Everywhere else, I'm going to have 0. And again, because we're including these 2 points at the ends, we're not including those 2 points at 0. So this is how we sketch it. Now in part B, so from there, we're going to try and determine whether or not this is a PDF or not. So again, we're going to try and satisfy those two conditions. The first one being that my probabilities must be greater or equal to 0. Okay, meaning my fx, or the graph, should be greater or equal to 0. Now this case doesn't really look like it because of this little portion here. Okay, because we have some negative portion of the graph, it means it's going to be describing some negative probability which doesn't exist, so this is not a probability density function. Okay, because fx is not positive or 0 for all of x. It's got some negative parts in it. Okay, so this function is not a probability density function. Now if we move on to question 3, we're going to have to sketch this graph as well. So let's try and sketch this fx. Okay, again, 2 different regions. Now it looks a little bit funny because we just have 1 and 0. We only have values, but let's just do as it says. So fx is equal to 1 in between 0 and 1. So in between 0 and 1, okay, we're just going to have fx is equal to 1. And everywhere else, I'm going to have fx is equal to 0. Okay, so this is the graph. Now from there, let's try and see if this is a PDF or not. So what's my first condition? I want all my probabilities to be greater or equal to 0. Okay, now in this case, yep. Okay, so it's got some zeros and it's all positive. So that's my first condition. My second condition is that the area under my curve must be equal to 1. Okay, because it's all probabilities. Okay, so area under the curve. So the area under the curve, and the curve being just 1, okay, fx equals to 1. So finding the integration of that between 0 and 1 will give me the area under the curve. So if I evaluate this, I get 1 minus 0, which equals to 1. So the area under the curve is equal to 1. That means fx is a probability density function. Okay, so those are the 2 conditions for something to be a probability density function.